this is the workshop for video talkthrough for OS 202, and this is part 1. So I'll assume you're at this stage, you have downloaded the files from the DLE and that you've unzipped everything and you've got a MATLAB window open and you are in the same directory. So make sure you navigate to the directory where you've got your workshop 4 files. Okay, and I've got the instructions here open as well. So the first instruction is to write a script that will read in the data file. So the data file we've been given here is carbon dioxide, atmospheric carbon dioxide data. And so first of all, I've suggested just to kind of explore a little bit the format. So CO2 data.csv, if I just double click on that, then you'll see that MATLAB actually does a pretty good job of recognizing what it is. Okay, so this data is in 2-column format, and the first row is, rather than being numeric data, is actually got the column headers. So month, so these are the months on the left-hand column, and carbon dioxide concentrations in the right-hand column. Okay, so we could just click on this, and if I go to my workspace in the MATLAB window, then you can see it's generated carbon dioxide with 161 rows and month with 161 rows. Okay, so you can do that. MATLAB will try and read it in for you just by clicking on it, but to do lots of files, then it can be a bit tedious and you might want to write a script to do that. So I've got a script here, which we'll look at in a minute. But first, let's just, we can see that the format is a CSV file. And one of the things you can do, let's just type into MATLAB doc CSV read. So if you've got a fairly simple format, then this function can be quite useful. Okay, so if we look at the first line here, m equals CSV reader file name. So it reads a comma-separated value formatted file into array M. The file must contain only numeric values. Okay, so if I try typing this, if I try to read in that file name that we've got, our CO2 data file, so let's just try that, m equals CSV read, and our file name is CO2data.csv. Okay, then I get an error. Okay, so what does it say? It says mismatch between file and format string. Trouble reading numeric field from file row number 1, field number 1. Okay, of course it's having trouble because that data that we saw in row 1 is not numeric, it's text. Okay, so that's why it's encountering a problem. But if we look at the second syntax command for calling CSV read here, this one here, R1C1, and look at the description here. It says it reads data from the file starting at row offset R1 and column offset C1. So we could actually ask MATLAB to read in our data, our CO2 data file, starting, offsetting the row by 1 and reading it from that point onwards, because from that point onwards it's all numeric. Okay, so I've started that in this little script here. So if we open that up in the editor, you can see that we have, I'm calling CSV read, I'm passing it the name of our data file, I'm giving it a row offset of 1 because we don't want it to read the first row because we know it's text and non-numeric, and a column offset of 0 because the second row, the first column, is numeric. Okay, so that's where the data starts. And I'm putting that output of the numeric data from this CSV file into array R, and I've then, just because it's slightly easier, defined our time and our Y time series as the first and second column. So in other words, T is then our time in month and Y is the CO2 concentrations. Okay, so I could just run that as it is. See, read data CSV pops over here. And if we look at our workspace, you can see that I now have, I've actually got 3 versions of exactly the same thing. So there's a lot of redundancy over here. Month is the same thing as T, they're all the same length. Okay. CO2 here is carbon dioxide concentration, which is the same thing as Y. And R is just the array of T and Y in columns. Okay, so that's just a useful thing to know for reading in CSV data. So let's plot our time series and check it makes sense. Okay, so we just do that from the command line. I'm going to get rid of this help window. Okay, it's useful to get into the practice of just checking things look like you expect them to look. Okay, so plot T, Y. I don't know where our figure is. Let's open up a figure. Okay. And so we can see this is a quite nice, clean looking time series with very strong periodic components. It's not noisy like one that we looked at in workshop 3. But it does have a trend. And so one of the key outcomes of this workshop is really to learn how to deal with real data that exhibit trends and how to remove a linear trend from a time series before you generate a power spectrum. And the problem with generating a power spectrum from a time series that does have a trend. Okay. So now we have we're partway through point 3. We've checked that it makes sense. Okay, so we're seeing a periodic change in carbon dioxide. This is month, again on the x-axis, just to remind you. So given our time series, what do we expect the Nyquist frequency to be? So the Nyquist frequency is going to be half of our sampling frequency. And if we just have a look again at this data, can we look at it here? Yeah, okay, so it's just going 1, 2, 3, 4. So this is in month. So our Nyquist frequency, we've got 1 sample per month. So our Nyquist frequency will be half of that, will be half a sample per month. The frequency resolution will be 1 divided by the total duration of our time series. So in months, our resolution will be 1 divided by the maximum value of T, okay, which is 0.0062. Okay, so that's our frequency. We expect that to be our frequency resolution